Hey, this is Jay joining you for another quick bite, and this time we're going over some basics for fractions that you'll need to know for this class. This is probably stuff you already know because Math 103 is a prerequisite, but just in case you need a refresher with some of these ideas, so let's get to it. Let's start with this one. Any fraction raised to an exponent, you can flip it over and flip the sign on the exponent. So a over b to the negative 2 can be written as b over a to the positive 2. Note that this works both ways, so that x over y to the positive 3 can be switched over to y over x and just flip the sign from positive 3 to negative 3. It may not seem very useful to change an exponent from positive to negative, but we'll get back to that later. This also works with an exponent of negative 1, which means that if you have x to the negative 1, which is just x to the negative 1 over 1, you can flip the fraction and flip the sign. This gives you 1 over x to the positive 1. And since any number raised to the power of 1 is just that number, we can see that x to the negative 1 can always be written as 1 over x. So, using this simple rule, you can freely move things between the numerator and denominator of a fraction as long as you change its exponent. Got an a to the negative 2 times b over c to the negative 3? We can move the a to the denominator and make its exponent a positive 2, and then we can move the c to the numerator and make its exponent positive 3. This rule and all other fraction rules hold true even when working with units, which is why dimensional analysis works so well. You know that speed is measured in distance over time, for example, meters per second, and you may have seen it written as meters times seconds to the negative 1. You can see that they are exactly the same units, and even written this second way, most people still read it as meters per second. This rule also helps us to understand compound fractions, where we have fractions within fractions. For example, acceleration can be measured as meters per second, like so. We can first change the numerator to meters times seconds to the negative 1. Then we can move that seconds to the negative 1 to the denominator, where it just becomes seconds, and multiplied by the seconds that's already there, so we have seconds squared. And you'll find acceleration written this way. But we can also now move that seconds squared to the numerator and write it this way, meters times seconds to the minus 2. You'll see acceleration written this more compact way too. So, keep these rules in mind as we dive deeper into measurements and dimensional analysis. Once you get accustomed to it, you'll find that you'll have an easier time solving problems with units, fractions, and exponents. I've been Jay, and thanks for joining me for this quick bite.